From here to the stars, I am your host, Stephen Euin Cobb. Our guest today is Dr. Catherine Asaro, who has a Ph.D. in chemical physics and a master's in physics, both from Harvard University. She is more widely known, however, as a science fiction and fantasy author, for which she won the Nebula Award twice. Generally, when talking about interstellar exploration, the focus is on the difficulties, the hurdles, the obstacles, and we'll get to those in a moment. But what are the benefits to be derived from robotic exploration missions to other star systems, as well as human missions?
Well, I think when it's a robotic mission, although you lose the human reaction, the human ability to respond to situations, you also lose a lot of the danger. And by danger, I mean the risk of losing human life. Mm-hmm. So you can get a lot of details from robotic missions. I don't think that you want them to take the place of manned or womaned expeditions. But certainly a lot of the details of the world and the environment and the conditions and, chemistry and physics and all that stuff, you can get a lot of that from, robotic missions. Mm-hmm. Ultimately, though, I think you need to send people because there's so much we can do that at this stage in the development of technology, robots can't.
Mm-hmm. How big a part do you believe that our building a space infrastructure will play in our launching of interstellar missions, whether this infrastructure is in Earth orbit or lunar orbit or even out among the asteroids?
You mean like a space station?
Yeah. I mean, I've heard Les say, well, we're not going to launch an interstellar mission from the surface of the Earth. So it'd be like... Well,
yeah. And his point, I mean, it costs a lot of resources to get out of the gravity well of Earth. Mm-hmm. So, yeah, I think it would be useful, not only for, further launches out into further in the solar system or out into interstellar space, but just because I think that's part of settling the solar system is to start building an infrastructure, first around, in the locale, in the neighborhood of our planet. Mm-hmm. But eventually we want to get out to the asteroid belt. And then, there's so many places to visit where we can set up bases and space stations in the solar system. And a lot of them would be useful for, making the next step out, outside of the solar system.
Mm-hmm. This question is a little bit more personal than most, or than any of the other ones. But your father, Frank Asaro, is the nuclear chemist who discovered the iridium anomaly, which led to the postulate that an asteroid collided with the Earth 66 million years ago and caused a mass extinction, which included the end of the dinosaurs. You earned a Ph.D. in chemical physics from Harvard University after receiving a Bachelor of Science with highest honors in chemistry from UCLA. And so I'm curious, what drew you to science at a young age when other kids in your neighborhood were out playing?
Well, okay, this is the funny thing. Mm-hmm. I mean, I was drawn to science from a very young age. I mean, I used to look at my father's, books and pictures, and he would take us sometimes to his work, or my mom when she would go to pick him up. We'd go in and he'd show us around the lab, and he'd show us cool stuff, like what happens if you dip a rose into... what's it? Nitrogen oxide. What is it? The thing that
liquid nitrogen.
Liquid nitrogen. Yeah.
Mm-hmm. I've
it's
seen that.
It's been a long time since I was 5 years old.
I saw a demonstration when I was in high school of that. Yeah.
Yeah. So I was fascinated with it, but I think there's something genetic in it. I mean, I just liked looking at pictures of atoms when I was really small. I thought they were really cool. The picture of the electron zipping around the atom and making all those orbits. Very simple pictures, but, way beyond my age. And I just thought they looked really cool. I used to sit around, I wanted to do chemistry or physics, and so I'd start taking toothpaste, trying to make stuff in the bathroom. And then one day it occurred to me I wasn't going to make anything interesting in the bathroom. But the funny thing was, I don't think my parents got that, because I was a girl And it was more conservative back in the 1950s and the early 1960s. And, you know, it wasn't something they thought of girls doing. My father was supportive of the idea. I mean, of the 4 people on that seminal paper where they proposed that an asteroid or a comet hit the Earth, it was Louis Alvarez, his son Walter Alvarez, my dad, and Helen Michaels, who was like my father's first in command at the, or whatever you say for civilian group, scientific group. And, you know, so he was supportive in that sense. But I don't think he really thought it was something women were that interested in. You know, he came from a different time and a different culture. The very, you know, Sicilian, I have Sicilian, mostly Italian, some Spanish, but, you know, some North African, a little bit, you know, but all very conservative cultures. So I don't think they saw it. I wanted to be a ballet dancer, and that's what they encouraged, and I was a ballet dancer for many years. I went to college as a dance major. But, you know, the science was in me. DNA doesn't care. For the most part, DNA doesn't care whether there's an X or a Y there, you know. There's not that many things that are sex-linked to genetically, you know, and it was in me, that desire to be a scientist and a mathematician. And I ended up switching in college. But it was always, the fascination was always there. And it was fun growing up around the stuff my dad was doing, you know, the way they used to argue about trying to figure out, well, what caused this? Why is there all this iridium and it's not supposed to be there, you know, and coming up with all these ideas and then shooting them down. It was exciting.
Okay. If humans travel to another star, the trip will not be like Apollo 11, which took roughly 4 days to get to the moon and roughly 4 days to get back. It seems likely to be a trip that lasts decades, maybe even centuries, with no one expecting to return to Earth. So what psychological stresses is this likely to put on people, and what can we do to reduce that stress?
Well, it depends how you build your ship. I mean, if we want to go anywhere, and if we don't learn any new physics, I mean, I'm sure we don't know all the physics there is to know. And I suspect there probably is some way to get around the problems with light speed and the impossibility of traveling more than certain speeds. But if there is, we don't know it. So with what we know currently, you know, the closest stars are, you know, 4, 5, 6, 10, 15 light years away. A light year, it takes you a year to go a light year. That's what it means. We want to go anywhere, even in the local region of the Milky Way galaxy. We're talking, you know, like you said, it could be hundreds of years. You can't live in a tin can and have generations of people living there. It's just not feasible. So we would need to build what they call generation ships that people can live on and survive on and have a reasonably healthy life. And by healthy, I don't just mean that, you know, you are healthy within your body, but mentally too. So I think it's going to have to be big. You probably, because when you reach a place, it's probably going to have gravity, right? So you need to have some way to simulate gravity. Because if you have generations of people living in free fall, who knows what the condition, they won't be like humans who are used to living in a gravity field, especially if they live that way all their life. So, you know, you're going to need something that rotates. That's, with our current knowledge about physics, that's how we get, you know, the effect of gravity in something like a ship. Is rotation, you know, like you could have a wheel, like space stations, like the Stanford Torus rotates. So you get gravity in the rim, or what, you know, it has the same effect. It's not gravity in the sense that the Earth or the sun have gravity and they deform space-time according to general relativity and so on. This is gravity due to the effect of the rotation. It would take a lot of resources to build something like that. You need it really big. You need to have one that had living areas and areas for the scientific and areas for the economic, and you essentially need cities in space. We aren't talking about something small. If it's going to survive for 10, 50, hundreds of years, you need enough people on it so that if there's a catastrophe and a lot of people die, that it's not the end of your mission. And I mean, realistically, that's something you have to consider. There has to be a huge amount of redundancy worked into the systems, because who knows what happens up there. Something could hit it. Radiation could turn out to be more serious than expected. You have to be able to do repairs, solve problems, and keep people alive for an extended period of time in something that is, compared to a planet, quite fragile. So I suspect the resources to build it would be immense. It doesn't mean it's impossible. I mean, I think it's something that bears looking at.
Okay.
But it is a big investment of time and energy.
You mentioned altered physics, so to speak, or alternate drives.
Yeah.
Unproven drives, that's how I have them characterized in my list. Unproven drives, reactionless drives, hyperlight drives, Albuquerque, I think is how you pronounce it, drives. Do you have any confidence that they work now, or one day might be developed into something that works?
Well, okay. That's actually a two-part question. Would they work now? I think it's pretty unlikely with what we're doing right now. Because I remember when there was an anthology published about Stargate, the Stargate universe. And they contacted me and said, well, could you write a popular science essay about how the Stargate works? And I said, okay. And I said, how about me and my husband? Because my husband, before he passed, he was a NASA scientist, and he does work on, general relativity and black holes and accretion desks and all this stuff, and he knows a lot about that kind of physics. So they said, sure, as long as it's popular science. So, I'm good at taking what we scientists write and turning it into something. So that's what we did. And we tried. I'm telling you, Steve, we tried to find a way to make the Stargate work. And, he tried all sorts of things, black holes, white holes, exotic matter, this, that, And, we could find some ways to kind of make it work. They weren't as convenient as shown on the show, but, they might work, but the amount of energy was immense. We didn't really find anything realistic, but we didn't want to say that. So at the end we said, but, we're close to, the areas of physics are developing fast and these all hold promise, and, something like that. Like, we were on the verge of discovering And actually, I think that answers the second part of your question, which is I do think someday we're going to find new physics. Or all these things that are attempting to extend the physics now, eventually we will find out how they do it. The one I can talk about in particular, because I've published a paper on it, is this idea I came up with for, if you make your speed a complex number, all the problems in special relativity go away. You can get around the speed of light. You just leave the real axis and go into the complex plane for speeds and energy. Of course, it does have a little problem, which is, complex speeds don't exist. But and I remember when I published it, the American Journal of Physics published it, and after it was refereed, and it went through some, I had to respond to the referee's comments. One of the things the editor told me, he said, look, please make sure that you're clear in the introduction of this, that this is a thought game you're playing. Like, how Einstein used to propose thought problems in relativity? He wanted me to make sure it was clear I was posing a thought problem for people who wanted to think about stuff like that. That it's more like playing a game than actually saying we can do this.
Yeah, for anybody who didn't understand that complex numbers don't exist in reality, they might think, wow, we've got it now. We've solved the problem.
Yeah, right, exactly. But here's the thing. Okay, there are a lot of theories in physics that use complex numbers. I mean, that's all quantum mechanics is. It's all, it's a treatment, beautiful, absolutely gorgeous treatment, mathematical treatment, solving partial differential equations, mainly something called the Schrodinger equation. And your solutions are complex. And they're beautiful. They're utterly beautiful. To get something real out of it, you have to figure out how to get a real number out of this in a way that physically is verifiable and supportable. I mean, you can't just make something up. You have to say, we do this because. It has to be real physical reason. But it was possible to do that with quantum mechanics, and it is probably one of the most successful models of physical behavior ever developed. I mean, it's astonishing. And all of that fell out of what we didn't have with quantum mechanics was Schrodinger's equation. We had all the mathematical machinery to solve Schrodinger's equation. We just didn't have the equation. Schrodinger figured it out. He came up with it. And boom, we had everything we needed. There are other theories in physics, like, for example, poles in the complex plane can describe resonances in atomic and molecular processes. There's always a way to interpret the complex number in a way that makes physical sense. So you never know. I mean, eventually we may find ways to interpret faster than light speeds, which everything gets complex. Or at least, special relativity is the simplest case. And in special relativity, even when you go faster than the speed of light, everything turns into imaginary numbers. You have to worry about, complex imaginary parts of numbers, complex numbers. So, we don't have the tools or the theory to do that now, to understand what it means. As far as we know, you can't do it. But I wouldn't be surprised if we found, I mean, you've probably heard this before, that before the advent of relativistic physics and quantum physics, scientists were saying, well, we've learned pretty much everything there is to learn about physics.
Yeah, I've heard that.
It's a matter of refining things.
Yeah.
And then, boom, Einstein and Schrodinger and what's his name?
Planck.
Heisenberg and Planck, yeah, they all changed the world. And it was interesting. I'll give you one more example then. I love physics. I love talking about it.
Okay.
One of the things they said, well, there's this problem with Mercury. Its orbit doesn't behave quite the way that Newtonian physics expects. There's a little bit of an error in it. And we can't figure it out, but we're sure we will. Well, it turned out that little bit of an error was due to general relativity. It was the relativistic effect, which Einstein predicted when he designed the theory of general relativity. Special relativity, which doesn't take into account accelerations and so on, came first. It was when he developed general relativistic theory. He said, wait a minute, I can explain. Once he got it right, it took him a few tries, but once he got it right, he said, I can explain why Mercury's orbit doesn't behave the way it's expected to. It won't. It can't do that unless you take into account relativistic physics. So, I suspect we have, some huge new developments coming down the pike in the future.
Okay. By the way, I should mention that in case I lose you, there's a thunderstorm rolling through here. I hope I don't lose electricity, but if I do, I will lose you. So that's the explanation if I disappear, and we can slice that out. Mike, remember to slice that out.
Or you can leave it in if you want. I mean, you can tell people we had to delay this interview because tropical storm Isaias, or however you say it.
Oh, yeah. Yeah, I saw the picture you sent me. Yeah. Let's see. As a physicist, you deal with facts, which are based up by hard numbers. So you are in a unique position to ask for an assessment of which propulsion system seems most likely to be used for our first interstellar mission. What method of propulsion do you think we will use? And I'm guessing a conventional type, but maybe something advanced.
Well, I wish there was something that wasn't conventional, because conventional types are all, have substantial limitations. I'll talk about that in a second, but conventional types, I mean, you need a renewable source of fuel, of propulsion. I'm not an expert I'm not a rocket scientist. I'm an applied mathematician. So I'm a theoretician, right?
Oh, okay.
So I figure out, I solve Schrodinger's equations. I solve Einstein's equations. I don't design rockets. So, but from what I know, just being around it, something, for example, like solar sails, as long as there are stars, you have your propulsion. If you can scoop things up from the surrounding, space, even though we say it's a vacuum, there's a lot of stuff out there. If you can scoop up your fuel from the vacuum, it has to be some form of propulsion that gives you fuel. Ideally, could we develop alternate forms of propulsion that get around? Those are big things to get around, but that get around those problems. Essentially, in a way, we're asking for a perpetual motion machine, which, is physically not reasonable. But there must be some way. In fact, the Breakthrough Physics Propulsion Workshop, which was founded by Mark Millis, he was at NASA. I think he was at the one in Ohio. I'm not sure, but I think he was. He founded this Breakthrough Propulsion Workshop, which the basic idea was to find forms of propulsion that would allow interstellar travel to become more feasible. It's not impossible now. We have the technology to do it, but is it feasible? With all the energy and the resources it takes. And feasibility doesn't just mean figuring out a method. It means figuring out how to keep it going when you're all out there by yourself, 10 light years away from any potential source of help, or farther yet still. Feasibility also has to take that into consideration. And there were various sections to the Breakthrough Physics Propulsion Workshop. I was in the one where, ultra fast travel, that's what they call it. They were trying, because it was sponsored by NASA, they were trying to avoid anything that would look woo-woo, So they didn't say faster than light, they said ultra fast. But the reason I got the invitation was because of that paper of mine where I came up with an idea to circumvent the problems with special relativity. The idea was, can you develop realistic methods that make it possible to circumvent the problems that we're facing right now with, interstellar travel not being particularly feasible. And I think if the workshop, when Mark left, Mark was the driving force behind that, and he did an incredible job. And then, of course, when you're good at something, you get wooed away by people who want to make use of the fact that, you're good at stuff. So I think he got wooed away by some company. And then I don't even know if it's still going, if the workshop is still going. I haven't heard much about it for years. But I think the knowledge, the ability, the genius, if you wanted to use that word, to develop ways to do this exists. What we need now is the will. We need somebody to support something like the Breakthrough Physics Propulsion Workshop. Either that, or you need someone willing to put in the resources and the time and the effort, and they're going to be huge. Most people don't have those resources to create, a generation starship. So, there's two approaches to it.
Okay. As a science fiction writer, you've spent a great deal of work popularizing science and astronomy and physics and related topics. What part do you believe that inspiration will play in our ultimately achieving interstellar travel?
Oh, I think it's huge. Because that's what inspires people to go into the fields where you can solve all these problems. I read science fiction. I devoured it as a kid. I loved it. I'd go through 7 or 8 books in a weekend. And I didn't even know until many, many years later that I'm actually dyslexic. It's a special kind of dyslexia. I don't even know if dyslexia is the right word. They sometimes call it stealth dyslexia, because it's, what I was told was that my mind was designed to solve math first, and then I learned how to read. So I solved math before I learned how to read. And some people just have minds like that, and they're usually really good at math. But the way I got around it was I learned to speed read. I taught myself when I was a kid, like first or second grade. And I can do that with fiction. I can't do with technical stuff. I have to slow down and really make sure I'm not transposing or words or, letters or anything. Man, I would just blast my way through those novels. I loved it. So it's not surprising I was inspired to become a scientist when I was older. And I don't even know, when you love it as much as I do, it's like part of you. So I don't know if those two things were both a result of something innate, something in me that was drawn, to math and physics and all that. Or if, one inspired the other. I think they kind of fed off of each other.
Okay.
But, it depends on the person. I mean, Mark Millis, I remember at the first Breakthrough Physics Propulsion workshop at the opening session, he put up a picture of the Enterprise from Star Trek, and he said, well, this was a show. A lot of us enjoyed watching it. Maybe someday we can reach. And it was also inspiring in the view of humanity as better. That we reached a place where it was more, humans were more decent to each other. I mean, not always. There would be no show if everybody's nice to each other.
It has to be a conflict. Yeah.
Yeah, but just in the general idea was a federation or a interstellar association founded on the idea of treating people well. It broke a lot of boundaries, like the first interracial kiss. He tried to show women in strong roles. He had various ethnicities and races, and I think Star Trek has always, tried to keep that view of humanity. So it was inspiring, I think, to a lot of us because of that, too. A better future in all ways.
Speaking of TV and movies, on TV and in movies, people traveling between stars are often depicted in some kind of extended sleep state, which slows their metabolism. Sometimes it's cryonic, sometimes they appear to be at room temperature. Do you know of any research at all that supports these fictional methods of overcoming the huge travel times? And if not,
I don't think we could do. Oh, go ahead.
Oh, I was just going to say, and if not, what is your opinion of the probability of something being developed eventually?
I think something can be developed, or I don't think we could do it right now. I mean, this is the same problem I was talking about before. You go out there, it makes sense, right? Put everybody to sleep and just, keep them alive for 100 years, and then they wake them up at the destination. And it doesn't really matter that you're now 100 years out of sync with Earth because you can't get back to Earth. You leave it behind. When you get on that ship and they put you in cryogenic or whatever suspension, you have to do it with full knowledge you're leaving the life you knew behind. So it makes sense in those kind of terms. Does it make sense scientifically? I don't think we could do it right now. I mean, I know there are some people who are, making arrangements, I can't remember the name, but I read about some guy who's really rich and he's making arrangements to have his body frozen when he dies, and with the hope of being awoken at a time when he could continue his life, when science would allow him to continue living, that sort of thing. I don't think we're there yet. Especially if we're talking about a ship that's going to be in space for a century, several centuries. What if something goes wrong?
Or who's going to wake you up?
And then they say, well, you have to have one person awake or two people awake. And then, wow, I wouldn't want to sign up for that part of it.
Yeah.
And then people make movies about it, right? Oh, I woke up and I have to wake up this beautiful woman so we can fall in love and be together, for the rest of I don't remember the name of that movie, but Passengers, was that
Passengers, I think. Yeah, I watched it.
Of course, we all watched all those movies.
My favorite character was the robot. It's the bartender.
Yeah.
Let me ask you about alien life. Do you believe there is life, even if only bacterial life, somewhere in the universe other than Earth?
Sure. Yeah, I'm sure there is. We have such a small
sample.
Sample size,
Yeah.
yeah. And even here, there are indications that maybe there's some sort of, at a microscopic or molecular level, even some sort of life or fossils of life from Mars. I mean, there's never been any definite determination of that. But the question has come up, and what about the moons of some of the bigger planets? Is it not intelligent life as far as we know, at least not intelligent enough to try and reach us? Or maybe that does indicate intelligence. No, we don't want to talk to them.
Yeah, right.
Yeah, sure. And there's so many different forms that life can take. It doesn't have to be carbon-based organisms living in an oxygen nitrogen atmosphere. I mean, there's this brilliant novella written by Greg Egan called Wayne's Carpets about with these mats like seaweed or something on this planet. It's been about 20 years since I read it, so Greg, I apologize if I'm getting this wrong. But there are these huge mats, and when you did a Fourier transform of what was going on in the mats, the Fourier transform, which is a mathematical thing, showed intelligence in the way that these mats were existing. And I don't remember the details. I just remember when I read it, it was like, boom! It was brilliant because it was so different than intelligence as we've ever imagined it. You know, intelligence by Fourier transform of seaweed. But I think that's true. I mean, there's all sorts of different ways intelligence can manifest, including, and even if you just look at intelligence or life, even, you know, it doesn't have to be intelligent life. With molecules that are the type that we're made of, you know, it's not, making those molecules is not unique to our planet. I mean, they get made in space. All sorts of molecular chemical processes go on, even just on the planets in this solar system and their moons. I mean, some of those moons have all sorts of exciting things going on. So there must, I mean, I never subscribed to the idea that just because nobody's ever contacted us, there must not be intelligent life in the universe. I mean, that's ridiculous. How long have we existed? You know, how many billions of years have the universe existed? And we've been able to look for this stuff for what, you know, 50 years, 100 years, 200 years? I mean, in the local neighborhood, we just don't have the reach or the extent to find it. But yeah, I would not at all be surprised if all sorts of life existed out there, and even if intelligent life existed someday, sometime.
My next question was about intelligent life. Do you believe there's intelligent life somewhere in the universe? You already answered that one, so let me jump to my next one. Do you believe that there are civilizations elsewhere in the universe?
Do I believe? I mean, how, you know, it's
how do you
like
avoid it?
Yeah, it's not like it's something you can have faith in. You know, it's you need scientific facts to support that. But I don't think there's any scientific reason that says it can't. You know, a lot of times when people discuss this, they say, well, to reproduce the conditions on Earth with, you know, a star that would allow a planet like Earth to exist, and with a habitable zone, and with this and with that, and, you know, the evolution and the development of this. And it's like, basically you're saying that reproducing what happened that led to life on this planet is the only way to get intelligent life. And I don't buy that for 1 minute. I think intelligence implies a civilization, but not necessarily. In other words,
maybe.
Yeah, if you're intelligent in a way that you communicate with other beings that have intelligence, or if you're an intelligence that's like a computer network, so you're all connected, you know, I guess you could call that a civilization. But, you know, if you are beings that communicate with other beings, you're bound to form some sort of civilization. Will it be some exciting galactic civilization that we can go out into space and interact with? I don't know. I mean, you have to have the coincidence. Space is huge, you know. I mean, we're talking about a place filled with galaxies. I mean, it's almost unthinkably large, you know, even for astronomers who are used to thinking in those kind of cosmological terms. You know, we just know one little part of our galaxy. So the fact that no one's contacted us or we haven't found intelligent civilizations in this one little part, I mean, who knows what's out there? Maybe in 400 galaxies in the neighborhood to the left. There's no left and right in space, but you know what I mean.
Yeah.
That neighborhood over there.
Yeah. Well, let me ask you,
400 galaxies away.
Do you feel we should hide our civilization from civilizations more powerful and possibly aggressive?
That's a tough question. Part of me says, yeah. But another part says, how are we ever going to contact anyone? I don't know how to answer that, to be honest. Because, I think it's Carl Sagan set up the SETI program.
Yeah.
And then the Planetary Society is a very strong supporter of the idea of, sending out messages that were here. Or was it Voyager that went out there and broadcast a message basically saying, here we are.
It carried plates and I think a record. Like a phonograph record, so to speak.
But didn't it also have coordinates of Earth?
Yeah, in the plate. It was I think it was basically like a phonograph record that contained data. It contained photos and maps and diagrams and our location as well. Yeah.
And so, part of me, when I was young, was very excited about those thoughts. But that assumes that whoever comes is benevolent. But it's a human thing, the idea of conquest and coming in and, it's a fear, a human fear, or at least it's a fear Hollywood either creates or makes use of to make a lot of money.
In a movie, something has to go wrong in a big way.
Exactly.
Always.
And they're usually evil beings that look like bugs because people don't like bugs, right?
Yeah.
So it's a very limited view of potential intelligent species out there. I mean, I really don't know. I don't think we have the capability at this point. One Voyager or a few messages broadcast into space. Well, I mean, we're broadcasting all sorts of stuff into space now, not on purpose, but we're just sending out signals.
Yeah, TV and radio and military.
Yeah, but it's, the probability it'll reach somebody is probably not that high. That doesn't mean it can't happen. And then they have to have the ability to get here. And then they have to, if they were going to hurt us, they'd have, why would they? Well, if they could travel around the universe and do all this stuff, they could find lots of planets. Why would they want ours,
Yeah, I watched a movie one time where they were stealing our water. And water's all over this whole universe. It's like... Yeah.
Oh, I remember. It was that David Bowie one.
Is that the one? Could be.
I think so, yeah. They came to Earth to steal our water. And it's like, well, really? You can get out into space and you can't get water out there?
I mean, there are whole planets in this universe composed of water. The Earth's only got a tiny bit. It's like, just on the outside. Oh, my word. Anyway, okay. Well, I appreciate you taking the time for the interview. It was great stuff.
Yeah, that was fun. I had a great time. You are a wonderful interview, Stephen.
Thank you.
Really, I've always thought that.
Okay, well, thank you. That was Dr. Catherine Asaro. This has been From Here to the Stars, a video series created by the Interstellar Research Group. The IRG is a non-profit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. Find us online at irg.space. I have been your host, Stephen Euin Cobb. If you enjoyed this video, please hit the like button, and you can subscribe to our channel for other such videos. On behalf of all of us here at the Interstellar Research Group, I thank you.